Okay, hi there. So it's a new video for differentiation. Now I want to focus on a function. Say I have the function x plus 3, or let's put that 2x plus 3 and say 5x minus 4. And say the question is, what is the derivative of this function? So again, the basic rule on differentiation, say x to the n, the derivative is n x to the n minus 1. So this will not apply directly to a quotient of two expression. So this is wrong. So do not say that the derivative will be derivative of 2x plus 3 is 2, and then derivative of 5x minus 4 is 5, and then you'll say, oh, the derivative of the given function is 2 over 5. So this is completely wrong. So this will apply only on expression exactly written as x to the n, or if you have an coefficient, say you have any number to the n, then the rule will be you have a, the derivative will be a n and then x to the n minus 1. But this is completely different because you have a quotient of two expressions. So the question now is, how then should we differentiate a function like this? So we need another rule, which is what we call the quotient rule. In the quotient rule, so let's say the function is given as an expression u and v. So think of u and v as two expressions, as like 2x plus 3 and 5x minus 4. So this is like the u and this is like the v. So what is the quotient rule? The quotient rule is saying the derivative of a function where the function is a quotient or a ratio of two expressions, the derivative will be, it's the v, the one below, and then multiply that with the derivative of the numerator, the one on top, so du over dx, and then subtract the u that is multiplied to the derivative of the v with respect to x, and then everything, or divided by the expression in the denominator squared. So the derivative is v du over dx minus u dv over dx over v squared. Now you might say that's a little that's not easy to memorize, or that's not easy to understand. So let's take the function again so that you can see that this rule is actually very easy to apply. So above we have 2x plus 3, and then you have 5x minus 4. So the derivative will be the one below, so 5x minus 4. So take this one and then derive 2x plus 3. So times 2. And then minus, so you see you started here, you went up there, so 5x minus 4, and then derivative of 2x plus 3, so you have 2. Then from here, you go down, so 2x plus 3, and then, so from 2x plus 3 derive 5x minus 4, which is 5. And then everything, or divided by 5x minus 4, the one below, squared. So that's the quotient rule. So 5x minus 4 times derivative of 2x plus 3 minus 2x plus 3 times derivative of 5x minus 4. So it's like there's a cycle of process, or process going from bottom to top and then top to bottom over the square of the denominator. And then once you do that, all you have to do is to simplify what you have obtained. So this is basically 10x minus 8, and this is 10x plus 15, then over 5x minus 4 squared. Since you need more space, so let's have it here. You have the derivative is equal to 10x minus 8, and then you subtract 10x plus 5 all over 5x minus 4 squared. So 10x minus 10x will become 0. Negative 8 minus 5, so that will be negative 13 divided by 5x minus 4, which is squared. By the way, you don't have to expand 5x minus 4. You can leave the derivative in this form. So the derivative of 2x plus 3 over 5x minus 4 is negative 13 over 5x minus 4 squared. Okay? So that's how you use the quotient rule. Now, in a little while, I'm gonna share with you how we can easily memorize the formula, because if there are a lot of expression or variables there, sometimes it's hard to remember that formula. Some people will do it like this. So the function is u over v. Now I will call this the high because it's on top, and then I'll call the v low because it's at the bottom. So the derivative, to make this simple, is let's apply the rule first. So v du dx minus u dv dx all over the v squared. I can think of this as, so v is the low, so low, and then du dx is derivative of u, which I can just simply say derivative, so d of high, and then minus high, and then derivative of v, the derivative of low, so d low. Then all over, this is the low, which is being squared, so low squared. Now with this, it will be easy for you to remember it because all I have to do is to recite this formula. Low d high minus high d low over low squared. Okay, I'll say that again. It's very easy. Low d high minus high d low over low squared. Compared to memorizing v du dx minus u dv dx and v squared. That's not easy to remember. But if I say low d high minus high d low over low squared, low d high minus high d low over low squared, and then it's easy to remember the idea. So let's say I have a new function. Let's pick 3x, or say let's put a negative this time, negative 3x plus 2 divided by, say, 5 minus 2x. So applying the rule, so the derivative will be low, so 5 minus 2x, so low d high, derivative of the numerator, the high, it's negative 3, minus high, so negative 3x plus 2, so high d low, derivative of 5 minus 2x is negative 2, then everything divided by 5 minus 2x squared. So it's low d high minus high d low over low squared. But then after that, you just have to simplify the expression. Okay, so I hope that was able to help you in remembering the quotient rule easier. Okay, so that's it.